Welcome. This is the IND 780 QI demonstration. What you see in front of you are a couple pieces of equipment. We'll start with the scale. This is a gain and weight analog scale. We have a tub on top of it which will be the receptacle for the material. Material is rice and it's fed by a vibratory linear feeder. And the linear feeder's underneath a hopper. So the feeder will feed the material into the scale. So we have what some would call a gain and weight application. This is the IND 780 Mettler Toledo terminal. This is a multi-scale indicator. We have the QI application running on it, which means that it will handle up to 4 scales or 12 flow meters, or a combination of both. Then we have the controller for the linear feeder here, and what we'll be doing is changing the speed of the feeder. The QI is controlling cutoff of a constant speed feeder. We will change the speed to show differences in material feed. Now, material feed in a process, differences, could be natural variation that QI is great for taking care of, and that variation could be change in head pressure, change in material viscosity, some natural variation from different suppliers of material. Also could be some mechanical variation in your feeding system. So what QI does, it has a predictive adaptive control algorithm that actually models the process as the material feeds. It compensates for the flow rate as the material feeds slower or faster on that given feed, and adjusts its cutoff point to get to the same desired cutoff for your fill target, even with the natural variation. So the demonstration today is going to be to compare the traditional historic pre-act or historical control using history to the QI predictive adaptive control. So we have a little what we call Task Expert, a TE program running that just allows us to run this QI demo. I'm going to turn the scale off. I'm going to go to the target, and we're going to run to a 400 gram target. Our tolerance that you'll see on the display is 5 plus or minus 5 grams, and I'm going to run material path 1. Material path 1 has the standard historical pre-act control algorithm, which means it takes the history of previous feeds and uses that to adjust the cutoff. So the parameters are 400 grams target, tolerance plus or minus 5, and the display shows the tolerance on the Smart Track display, and then our algorithm we're going to run is the historical pre-act or traditional feed control. So we'll turn the scale on. The scale will automatically tear in the terminal, and then we'll start to feed. Notice the flow rate here of about 30 or 31 grams per second. We're going to 400 grams, so that's the larger number, and you can see we hit 400 grams dead on. Let's try that again. Again, still using the historic pre-act control, not changing anything on the feeder speed or the target. And keep in mind, this is a pretty stable process. We're in a conference room. Nice consistent flow of material, so without any variation we should be close to or at 400 grams. So we hit 400 grams again. We never changed the feed. You could have looked at the flow rate, it was the same. Now we're going to make one change. We're going to change the flow rate, and I'm just using the controller here to change the pot to change the speed or the frequency that the vibratory feeder is using, which will change the speed of the fill. And you'll see that when you look at the flow rate on the display of the IND 780. So again, nothing changed except you'll see the flow rate in the upper right change, and the time will be different. You can see now we're running about high 40s, low 50s grams per second. And as you would expect with historic control, we greatly exceeded our target. Now this could be, in a process world, this could be due to the viscosity of the material, getting lower, so flowing more freely. This could be due to the head pressure of the material increasing, which would allow the material to feed faster. So if we turn it down, conversely, and maybe we say that the material now is feeding a little bit slower, or back to our closer to our normal feed rate. Now the historic algorithm has to go back after it has overfed. Chances are now it's going to underfeed slightly. So we're 10 grams under our target of 400 grams. Our feed before we were well above our 400 gram target, and that's what happens as variation occurs. Your historic control can only use history to make changes, so it's going to chase itself back and forth. What they do in the process world is they put filters on that so it doesn't abruptly change and chase itself so much, but you end up with always using history to try and control something a process that you're running currently. So what we're going to do is we're going to turn the scale off. We'll go back to that target page, and we're going to make one change. 400 grams is our target, 5 is our tolerance. We're going to go to material path number 2. Material path number 2 has been programmed to use the QI predictive adaptive control algorithm. So there's your material path 2, and our same target and our same tolerance. So nothing else changes. Turn the scale on, and we'll run the same couple tests. So the beauty of the predictive adaptive control algorithms from Mettler Toledo is that as the feed occurs, the algorithms are building a model of the feed during the feed. So you'll notice we're running about 28 grams a second. We're trying to get to 400 grams as our target. And this is the first run from QI. So right out of the block, we hit 400 grams as our target. And you notice the flow rate, about 29-30 grams a second. Let's go ahead and speed that up. Again, we're not changing anything else except the flow rate. We're using predictive control to actually model the process and predict when to cut off the feeder to obtain the proper target that we have programmed. So now you'll see in the upper right we're running at about 45 grams per second. And we hit 399 grams as a target. So that flow rate almost doubled, which would have sent traditional control way over target. And we hit 399 on a 400 target. So let's turn it back down. Here's this case of kind of chasing its tail with a historic preact. And you'll notice how far we've turned it down by viewing the actual flow rate there in the upper right. So now we're down to the low 30s in our gram per second. Again, still our 400 gram target. And as we're approaching the target, we're building the model and we're predicting where to turn off the control to the feeder. And there we hit 400. Right on the mark. So we'll try that one more time. Let's go back up. Again, as we go higher, flow rate increasing. Could be an increase in head pressure. Could be an increase in or a decrease in viscosity due to another supplier's material. Maybe some mechanicals, some changes in your mechanical delivery. Notice now we're at 46, 47 grams per second. And again, we want to hit that 400 gram target. 399. And notice again we significantly increased our flow rate, which again on historic systems would have sent us way over target, giving away material and again chasing ourselves back to a point where we have to constantly adjust for something that's happened in the past.